Hello friends, welcome to the next algorithm of machine learning, logistic regression. We have so before actually starting this algorithm, we must be knowing the linear regression algorithm that we have already seen, and the classification systems, how exactly it behaves, that should also be known. Why I'm talking about this? Because linear regression's extension is a logistic regression, and why classification? Because logistic regression is a classification algorithm, because we have a confusion in the names, but it's used for classification system, that's why. Okay, so what is logistic regression? Logistic regression is the appropriate regression analysis to conduct when the dependent variable is dichotomous, that is binary. When we are having two classes, 0 and 1 class, so in which particular class it will go, that we have to identify. Like all regression analysis, logistic regression is a predictive analysis. It's used to describe the data and to explain the relationship between one dependent binary variable and one or more nominal, ordinal, interval or ratio level independent variables. Remember that though the name of algorithm carries regression, it is used for classification. Okay, so general identification is logistic regression are the perfectly suited for the binary classification, that when we are having two output variables expected, that time logistic regression plays one of the most important role to classify them. Now how exactly logistic regression does the classification, that will go step by step. Okay, so there are three ways to perform logistic regression. Binary, one of the most commonly used classification system here, like only two outputs are expected there, possibility like spam or not spam. Second is multinomial, where more than two are possible, like vague, non-vague or vegan. So in this way, or ordinal logistic regression, like we are having the ratings, three or more categories with ordering, like movie rating from 1 to 5. So these are the way by which logistic regressions are possible, but most suitable for binary logistic regression. Let's consider one example. So we know that, what we know, linear regression. So y is equal to b0 plus b1 into x. That's what we have. B0 is the intercept, okay, and the b1 is the coefficient, that is slope, and based on that we are going to find value of y. Okay, so if only one input is there, that case it's simple linear regression is possible. But when we have multiple inputs like x1 till xn, that case it's a multiple regression. So multiple different coefficients and multiple intercepts are, single intercept is possible in that case, that we know. And how it's applied actually? So let's have the experience and salaries example that we have seen. You might have identified this already. If experience on this direction, salary in this direction, so as experience increases, salary also increases proportionally. And when you plot a line like this, it means that they are linearly connected, and equation of this line is y equal to b0 plus b1x. Okay, in this way it's calculated. Okay, so this is how the linear regression is possible for the data which they are linearly connected. Okay, now let's have a new problem. A company has provided an offer by email to their customers. Okay, to their customers, and whether that particular customer has taken this order or not is presented by this graph. See how. So on x side we are having the age of the customer, on y side I am having the action taken. Action means whether the customer has purchased this particular item or not. It's presented here. See, these are the red dots present here. They are showing the action generated by the particular customer. So these are almost no, means 0 means no and 1 means yes. So they have purchased it. Okay, so if you consider this problem, there is no any other possibilities present between 0 and 1. Okay, 0 and 1 possibilities are not there, only 0 and 1 is possible. So it means that output is in classification format. So what's there in between, that we can't actually identify. Okay, so how to do this one? So for example, if I am going to apply the linear regression in this case, I'll have a line like this. Okay, in this way, line means most suited line, fitted line will be something like this. But if you generate the output generated will be presented in this also. See the three different points I have just highlighted there. If I exactly prediction is done exactly on this line, then it's okay 0, or exactly here it is okay 1. But the problem is that if the points are present in between these, then what action you are going to generate? What is action, 0 or 1? It is not specified. 0 and 1 will be identified only when the result is on this line itself. So if they are on this particular area, then it is not possible to identify the action perfectly. Now to identify that action perfectly, what we are going to do? So for this case, see, if you go to previous slide, okay, so below this means if age is below this, okay, almost all are not taking the offer below this, and age is above this, then almost all are not taking the offer. That's why if line is not exactly straight over there, or not exactly straight from this direction also is okay. So what we'll do, in this way the line can be formed. Okay, so this is actually not a linear regression now onwards, but we can identify that above this the action is offer is taken, and below this the action is offer is not taken. In between that we have a confusion. So the line is like this, but the points are not lying on the line, they are far away from the line. So exact decision of making 0 and 1 is not possible. So what we will do, let's start from this. This is your equation of the line. Okay, so here we will come with the introduction of logistic regression, equation of the line. And now let's come with one statistical function called as sigmoid function. Sigmoid function is this: p is equal to 1 divided by 1 minus e raised to minus y. And now if I replace this sigmoid function in the linear regression, I'll form this equation here. See, so my equation is this. So this is the equation of the logistic regression. And now if this equation is generated, what exactly happened with the line which I have formed on that particular plane? So let's see, if the line is like this for linear regression, this line is transformed in this particular part. So it will have a curve like this. Okay, we'll have a curve like this, in this way. And this is the statistical model of the logistic regression method here. Okay, which one? So this is what we are having, the statistical model of logistic regression. How exactly this logistic regression will behave, this particular line or this curve will behave, let's say this. Now on y side we are having actual values, on x side we are having the input parameters there, and if I plotted them, this is the equation of this particular line. So line is not exactly straight now. So line having this curve. Why the curve has happened? Because the sigmoid function I have applied to it. That's why this line has become curve. Okay, now let's see how the predictions are possible now. So predictions are actually in the form of 0 and 1, but the line is not actually showing 0 and 1. If anywhere the line will have a point. Now let's consider that ages. Age is my input variable. I am going to do the predictions with the help of this. And y side, actually I am not having the dependent variable now. I am putting p hat, that is the probability of the output. Probability of the output, how probable the output will go to 0 or will go to the 1 class there. Okay, so let's consider 4 ages I have taken here for prediction: 20, 30, 40 and 50. Okay, for these 4 ages I want to do the predictions, whether we will take the offer, that is 1, or whether we will not take the offer, that is 0. Okay, so any one of these can be identified, and let's see how it is identified. So I'll project them, these particular values, on the line or this curve. So if you go here, 20, if I projected on this line, it is having probability, that is 0.7%. 30 if I am projected on this line, it will having probability 23%, and 40 if I am projecting on this line, it is having 85% probability. 50 I am projecting on this line, it's having 99.4% probabilities. So my output variable I am considering as a probability. What probability is that this particular data or this particular input will go in the output? In which output? Okay, that's I not considered. Okay, so output variable is your 0 and 1, but not exactly 0 and 1 is identified. It is identifying the probability out of it. So this is probability identification is done in the logistic regression class. and in the final predictions. Now let's see how final prediction is done. So I have converted that data in the form of predicted dependent variable y hat. Okay, getting this? Now let's consider it. I'll keep this center of this particular curve. 0.5 is the center of it, probability center. Now the probabilities which are below 0.5, if you go to 20 here, projected below 0.5. Okay, it was 0.7%, so output is class 0. Okay, if you go to this, that is age 30, it is also 0.5's level. Okay, all the values which are below this 0.5 level will be projected to output 0, and all the values which are above this 0.5 level will be projected to 1. So here age 40 we are having y hat is equal to 1, that is probability will be 1, and for this case also, that is age is equal to 50, we are having y hat is equal to 1, that is probability will be 1. Probability is 99%, so output will be 1. In this way, the classification systems are created with the help of logistic regression. So output is probability. Okay, so you can see probability output is in a regressor continuous format, but it's converted in the form of the classification system with the help of logistic regression by considering the center of this particular curve for probability identification, above 0.5 or below 0.5. Above 0.5 is class second and below 0.5 is class 1. So in this way, the prediction systems of logistic regression behaves. Now, what are the advantages that logistic regression is having? It it performs perfectly well when they are linearly separable. Okay, if they are not linearly separable, then it's very difficult to identify it. Logistic regression is less prone to overfitting, but can overfit high dimensional data set. You will require, there are two techniques called as L1 and L2 regularization to avoid overfitting of these scenarios. Overfitting means perfect fitting on the data is done there. Logistic regression not only gives the measure of how relevant the predictor is, but it also gives direction of association, positive and negative. It is easier to implement, interpret, and very efficient to train. Okay, what are the disadvantages? Main limitation of logistic regression is assumption of linearity between the dependent variable and the independent variable. In the real world, the data is rarely linearly separable. Remember, if they are linearly separable, then rather than logistic regression, there are many more algorithms are available which give the effective output. So most of the data would most of the time data would be jumbled maze. In number of observation, if the number of observation are less than the number of features, the logistic regression would not be used. Okay, it may lead to overfit. Okay, so remember this. Logistic regression can only be used to predict discrete functions. Therefore, the dependent variable of logistic regression is restricted to the discrete number set. Okay, these are the prime disadvantages that logistic regression is having over here. Okay, actually while performing the operation, that I will show how exactly this system which is shown on the screen, AUC-ROC curve is used here. AUC-ROC curve is a performance measurement for classification problem at various threshold settings. It's a probability curve, and ROC is a probability curve, and AUC represents the degree of measure of separability. Okay, it tells how model is capable of distinguishing between the classes. Higher the AUC, better the model is predicting zeros as zeros and ones as one. By analogy, higher the AUC, better the model is at distinguishing between patients and disease and no disease like. Okay, so its curve is plotted with TFR, that is true positive rate, against the false positive rate, where true positive rate on y-axis and false positive rate is on x-axis. I'll show this practically how exactly AUC and ROC curve will be used here. This is used for a classification system which contain the probabilities. Remember, logistic regression is a probability based model, probabilistic model. So many such models are available in the probability studies. So wherever probability models are used, they are treated differently than the actual algorithm. So let's go for identification or using the logistic regression now. Logistic regression, we require the same packages which we have used for the previous algorithms also. But what data set I am having? So the example which I have shown to explain the logistic regression, similar kind of example I will take here. So let's go for that. So I will go to logistic regression, and the data set is, okay, let's use this data set. Social networking ads. So the company is showing advertisements to their customers. Okay, so this data I am taking: user ID, gender, age, estimated salary, and purchased or not. Okay, this is what purchased or not. Okay, so the ID of that user, gender of it, age of that particular user, estimated salary, it's not exactly the perfect salary, estimated salary by the company is given there, and after advertisement is shown to particular customer, he has purchased that item or not, that data is recorded. So we have purchased means 1 and not purchased are 0. You can say this one: many customer have purchased also and many customer have not purchased also. See this. Okay, so the data set is identified this, whether it's purchasing or not purchasing. Now what's the application of it? We'll build a model while logistic regression based on that, and next time whether you have to show this advertisement to this kind of customer or not will be found by this, whether this particular customer, new customer, is having capability to purchase this item or not, that we can find with the help of this data set. That's why predictions are required to work with this data set which is shown you on the screen. Okay, so let's consider, before actually using the data set, I want to analyze it first. So this is my output variable and I require the input variables. So let's take it. For example, if I consider user IDs, what do you think? User ID is having any impact in the output? Okay, not actually. The IDs, roll numbers, serial numbers, they will not have any impact in the output, so they are discarded. If you go to the second, gender can have the impact in the output, male and female, but we'll see this concept. What exactly is required here? We require a pre-processing step. Male and female are written in the string format, so they need to get converted into numerical format. So what I'll do, I'll have only two input which may have highest impact in the output are this age and estimated salary. They will perfectly classify your algorithm whether it is going to purchased or in not purchased format. So what I'll do, my decision is I'll take age and estimated salary as input and purchased is the output here in my case. Okay, so let's create this. So let's read it. Let's continue with your algorithm. Okay, so import pandas and numpy. Now yes, I'm reading this file now. Social networking ads I just shown to you. Open that and let's see the things which it contains inside it. Okay, so shape, 400 rows and 5 columns are there. 400 rows, 5 columns. Okay, so customers information, 400 customer information maintained inside it with the 5 columns. Let's check whether any missing values present there or not. Data.isNull.sum. So no missing values are there. That's what I have shown here: user ID, gender, age, estimated salary, and purchased. So these are the names of the columns. Data.columns, user ID, gender, age, estimated salary, and purchased. Okay, these are the columns which we have. Out of these columns, I want to use column number 2 and 3. So 2 to 4 by using data.iloc. I'm using this, or you can directly write the names also, age and estimated salary. But I'm using this method here. Data.iloc all the rows, but column number 2 to 4. So this is 0, 1. This is 2 and 3 only are taken. 4 is not considered, as we know iloc is having this facility. Okay, so we'll be taking this, then purchase output variable in y and check the head. So age and estimated salary will be my input variables, and based on that I'll be forming the model of logistic regression here. Okay, and now in y, just see how many outputs are possible. Yes, it is 0 and 1 are present only inside it, and if I going to have a set, then also output is same. So only 2. 0 means not purchased and 1 means purchased. Okay, so these are the two output variables I am having in the y. Okay, so there is one more describe I am using here. I'll show the meaning of describe later words, why to describe this data set. Okay, that's done. Now let's go for trend test split. Okay, so from sklearn.model selection, import trend test splits. I'm reading this particular function here, and then I will split my data into these four different subsets like x and y input variables, and 4 means x train, x test, y train, y test. Okay, they are separated. I'm keeping random state again 0 here, and the default test size is 25%. 25%. So my task will be now easy for me. That is, length of x is 400 and training is 300 and testing is 100. Correct? So exactly 100 entries are going into test data set. Correct? Okay, so 400 plus 400 are divided into 300 and 100. They are again you can easily find they are not in sequence. So let's see the training data's head, xtrain dot head. Okay, check it out. Can find it. Yes, 250 entries first, then 63, 320. They are randomized. And if you go to test, x test. Okay, so it's also randomized entries. 100 are present over there. Okay, so which we will be using for testing the final output. Okay, and now let's read the logistic regression model here. From sklearn.linear_model import logistic regression. So linear model itself contains the logistic regression class. Okay, as we have seen, logistic regression is extension or the modification of the original linear regression there. Okay, so let's create it. Classifier is equal to logistic regression. As it's a classifier objects, I'm giving its name as a classifier, not compulsory. You can give any name also. Okay, now fit it. Logistic regression I'm fitting xtrain ytrain by 300 entries, it is fitted, and now algorithm is trained with the given data. Our logistic regression with the sigmoid function is formed. Okay, so once this is done, so let's go for prediction. Yes, classifier dot predict x underscore test is predicted, and let's print the ypred. Okay, so this is the predicted outputs of ypred. Check the output. Okay, so output is having all zeros. Yes. Okay, so what I'll do, I'll make the original data set first. See whether it's containing all zeros. Not actually, it's containing ones also. See this. Actual output contains also ones, but the predicted output is not containing one. It means that all the entries are classified inside the single class. All entries are classified inside a single class. Why this has happened? It means that algorithm is not behaving correctly, or there is some problem present over here. Okay, what exactly the problem is, that also I'll carry out here. If you see the confusion matrix, I'll just identify the confusion matrix. Yes, now see this, 68 plus 32, 100 entries are present there. Out of that, 68s are matching with 68 and these 32 are completely mismatching with the 32. It means that the problem is the model is having some denominations towards a single feature. Means one feature is denominating in the output, is dominating in the output. So domination is present. It means that now just revise the thing that we have learned in machine learning prerequisites. When we are having dominations in the output, it means that the data scaling is required. One thing we need to I need to make sure that when output is generated in only single class, it means that this algorithm required the scaling, this algorithm required the normalization. Or one more thing, probability based model of machine learning require the scaling of the data. So it means that there is a single function present. In the single function all the variables are used. Okay, so magnitude of the data may affect the output. Remember, magnitude of the data is affecting the output. Which magnitude? See, if you see age ranges from, okay, I'll go above again. See here, describe. So I'm describing this. So age ranges from, minimum age is 18, maximum is 60, and estimated salary minimum is 15,000, maximum is 1,50,000. It means that estimated salary, this particular column, is dominating in the output. Okay, dominating in the output, and age is not having any impact in the output. So what's the solution on that? We will feature scale, means we will standardize this data. We will use standard scaler on this data, or we'll use min max scaler on this data. So what we require, we have to make the ranges of both of these columns to same. How to do this one? So let's do. So from sklearn dot pre-processing import min max scaler. Okay, it's imported, and let's do the scaling of this data over here. Let's use scalar is equal to min max scalar, create the object, and like XS is scale data, okay, scaled scalar dot fit underscore transform. It's used only when we are using probability based model and the output is dominating, one feature is dominating in the outputs. In that case we're going to apply this. So X transform X, yes, okay. So let's see this, what's the problem. In max scalar, scalar dot fit underscore transform, S is remaining, yes, okay. Let's see this, and now after this we'll see whether output is scaled well or not. So XS, this is XS, you can see this, they are scaled within the same range, but I want to describe it. So let's describe it. PD dot data frame, okay, convert data frame and then describe it. So now we'll see it correctly because output is in array format. Describe is a function of data frame, so I convert in data frame then dot describe. See this, now the minimum value of both are same, they are scaled down or scaled, okay, or both are scaled down in the same range 0 to 1. Their relation is not changing, only they are scaled down to the same range so that they will have same impact in the output. Okay, so that's what I have done. And when I imported trend test split and I have actually splitted the data, I'll use the scale data over here. So this is XS, getting this. So I'm using a scale data here. Now scale data I have identified and then splitted, so remaining things will be same. Okay, this test will not work because head is a function of data frame and test data is now in array format. Okay, remember this. Okay, so I'm skipping this statement. Let's create the object, feed the data, predict it and print the predicted values. Check it out. Yes, now this is the combination of zeros and ones, means I can consider that the output predictions may be something correct, maybe, but I want to use the characterization of classification systems now to see whether output generated by the classifier are correct or not. Okay, so they are now combination of 0 and 1, and Y test and Y pred they are almost having the combination of 0 and 1. I want to make them in front of each other. So to do this one, I am using result is equal to pd dot data frame actual Y test comma predicted Y pred, and let's print the result here. So I'm printing the result. Okay, you can check it out now. Result I'm making them front of each other. So 0 0 0 0 all. So here 1 1 is present. See, correct, till this they are correct. If you go ahead, almost everywhere it is same, correct. See 0 0 0 1 1 1 1 1 1, almost entries are matching. Yeah, is that? No, this is not correct. Actual is 1 0 is predicted there. Okay, take one mismatch I have found here. Here also 0 expected, 1 is predicted. Okay, but we're going to make the summarization of it by reading the accuracy score and the confusion matrix. So let's read it. Accuracy score I'm importing from matrix, confusion matrix, and the classification report also. Let's print it. Yes, now check it out. In confusion matrix, class number 0 and 0 out of 68, 67 number of time it's matching, and for class number 1 out of 32, these two 32 22 numbers is matching. It means that 67 plus 22, 89% is the accuracy of this algorithm is. Yes, check it out here. Okay, and now individual class accuracy is different here. Here recall we have 99% for 0, means out of 68, 67 are matching, and here 69, it means that out of 32, 22 are matching. Okay, and for this case precision, out of 77, here 67 are matching, and here in this case out of 23, 22 are matching, that is 96%. So we are achieving from here 68 will belong to class number 1, 32 belongs to class number 68 class number 0, and 32 belongs to class number 1 in this way, and we are achieving the accuracy 89% here. Getting this? Previously it was 68%. I applied it and now perfectly classified. I'm going to have the perfect output, almost above 80% accuracy. Means it's considerable and can be used for prediction of the results from there. And now let's do single entry prediction here. So let's enter the age. For example, age is 56. Okay, then I'll enter the salary. Salary is 120, something like this. And now let's create the array of it. Okay, so this array is new array I have formed. An important thing that to remember, that when you are going to do the prediction, we require to transform that data also, because the model is built on the scaled data, that is transformed data, scaled data. So when you are going to do the prediction, that data should also be in the transform format. So new, this is I am giving here, transforming that by using scalar.transform, not fit transform. Fit transform means take the pattern and then transform it. Transform only will identify, because pattern is already identified with the scalar. Okay, so let's transform it and now predict. Okay, so I'm predicting it here. Pred is equal to classifier.predict new. If pred is equal to 1, we'll purchase the item, and pred is equal to 0, it will not purchase the item. Let's see what exactly it's predicted. Okay, yes, he will purchase the item. When age is 56, salary is 1,20,000, then he will purchase the item. Okay, so this is how I identified. I've done the predictions over here. Now let's make some different things. Enter the age. I'll enter the age like 27, and then I'll enter the salary like 30,000. Okay, so it may be possibility that the particular person, so done, run this, and yes, will not purchase the item, because prediction will be 0 in this case. It means that the algorithm working correctly, 89 with 89% accuracy present over here. Remember that. And based on this we are generating the results here. But okay, all the things are done. We have built the model, we have found the accuracy, we found the we identified the outputs also perfectly, they are working. But few more characterization that we need to remember about the probability based models. So few more probability based models are also available in machine learning. That time also I will revise the same things again. Now let's see this one. There is a function called as predict probabilities. Now if I want to find the probability predictions, this particular function is used. I will run this and let's print predicted probabilities. Why? Pred and probab. So classifier dot predict probab. So this predict probab function is used for predicting the probabilities for all the 100 entries present inside it. So what are the probabilities present? Check this. Now okay, these values are 0 to 1. I'll just multiply them. So we'll go to percentage format. Now see, first entry present here, it contains the probability 79% for class 0 and 20% for class 1. Okay, second entry 75% and 24. Now we just can check it which contains high probability. So this is class 0, 0, 0, 0, 0, 0, 0, and here class 1 is present. Okay, because class 1 contains 60% and class 0 contains 39% probability is present here. Here 95, again here class 1 probability is there. This is class 0, 0, 0, 0, 0, 0, 0, 0, here class 1 probability. Okay, if you add them, it will become 100% there, but which is having high probability, that is identified over here. That's what the probability identification. This predict probab will predict the probability of the classifiers, and this function method is applicable only to the probability based machine learning models. Okay, so what's the advantage of using it? Let's go for ROC AUC curve, how exactly it is used there. Now I'll go to my theoretical concepts and then revise it again. Now see, so AUC-ROC curve is performance measurement for classification problem at various threshold settings. ROC is a probability curve and AUC represents a degree or measure of separability. It tells how much model is capable of distinguishing between the classes. Higher the AUC, better the model is at predicting zeros as zeros and ones as ones. By analogy, higher the AUC, better the model is at distinguishing between patients and disease and no disease. Means just a comparison I am showing it. The ROC curve is plotted with TFR against FPR. TFR true positive rate, FPR is false positive rate, where TFR on y-axis and FPR on x-axis, like this. Okay, let's see. this particular area is called as AOC. Okay, AOC. Okay, which the area which is covered by the curve, that is AOC, and this is ROC. Okay, so on this x-axis I am having false positive rate, and on y-axis I am having true positive rate. So based on that, these outputs are generated. Now let's see the curve for this. Probability based algorithms can have this particular curve generated, and we can easily find how effectively the algorithm is classifying class 1 and class 2. Okay, so that can be seen with the help of this AUC-ROC curve. So let's go for this, how to do this one. So I'm importing the matplotlib.pyplot as PLT. Okay, and from sklearn.matrix I am importing the function ROC curve and ROC AUC score. ROC AUC score. ROC AUC score is identified with the help of the probability, with comparison of probability and the y-test. Okay, so I have imported that, and now let's see here. Classifier.predict probability x-test. I am using only the last column, that is this column only this column. Okay, so that will have the impact, means the probability being in the second class, that is class number 1. Okay, so that's I am using only that by this method. Okay, that I am showing in y-pred probability. Then ROC curve containing two parameters, same parameter for score also are available. ROC curve will have y-test testing parameters and their probability parameters present here. Okay, y-test and probability. What's the probability that it is going on the class number 1, if it is below below 50 or above 50. Okay, so based on that, true positive rate and false positive rate they are identified. Okay, so these two are identified here, and let's go. AUC is equal to ROC AUC score. Again same parameter I am providing, the test value is 100 and their 100 probabilities, they are also mentioned there. Based on that, value of AUC is calculated, and now let's plot it. How to plot this? PLT dot plot true false positive rate on x-axis, true positive rate on y-axis. Okay, remember this is not different, this is not difficult to identify FPR and TPR. TPR, true positive rate, is the precision itself, and false positive rate is the remaining values, means the values which are positive but for not first class, positive for the second class. Okay, that's what false positive rate is. Then label I have given data 1 AUC. So here AUC score I am printing on this particular plot at the location 4, this position hai, plt.legend LOC is equal to 4, at location 4 this data will be printed. And now let's see, so how it is generated. Yes, now you can check it out. Okay, this is the area of AUC, and started from this direction, and how it is changing. You can see AUC score is 95%, 95.45. It means that's very high, should be above 80%. 95% AUC score is present, means area which is covered under AUC cover under this particular line is 95%, and above this line is almost 5%, means 4.5%. Here it is 95.5% is covered there. So if it is covered much, it should be covered as much as possible. Okay, so it will represent the most accuracy of the algorithm. Let's see how exactly this system will perform. What is AUC? An excellent model has AUC near to 1, which means it has good measure of separability, how it is separating between the classes. The poor model has AUC near to 0, which means worse measure of separability. In fact, it means it is reciprocating the result. It is predicting zeros as ones and ones as zeros, and when AUC is 0.5. It means model has no class separation capacity whatsoever. Let's see, for example, so these are my threshold values. These are true negative values, these are true positive values. True negative and true positive. So true negative values are true, means they are all 100% perfect, and in true positive all 100% are perfect. In this way, in that case AUC score will be 1, and you will have a curve like this. In this means 100% area is covered in AUC. Okay, 100% area is covered. In that case, classification is perfectly done. Okay, all true positive values are matching. And if something like this, so some true negative are encoding in true positive, some true positive are encoding into true negative. So these are we call as false negative and this we call as false positive. In that case, maybe AUC score is 0.7% and our curve will be something like this. So some 70% area is covered under this curve and 30% is under over the curve like this. Okay, and now see both are on each other. See, so AUC will be 50% and we'll have a straight line presented here. So 50% is above, 50% is below in this way when AUC is 0.5%. And now the last one, true positive values are true negative and true negative values are true positive. Say this complete inverse is there, means we are having AUC score as 0 and the curve will be like this. The area under the curve is 0%. It means that classification is 100% wrong. This is how the ROC AUC curve will show you, and this will work only on probability based model. So on logistic regression it is possible, and our curve is far much better. It's containing 95.45% area under this particular curve, and so that it identifies that the classification system which is used over here is working perfectly and is also having a scope of improvement by 4.5% also. Okay, so in this way the AUC-ROC curve can be used so much easily. Now some few more possibilities are there, few more things that I can make use of it here to identify the actual outputs. Let's fill in the confusion matrix, and let's fill in the confusion matrix here, this one. And now how accuracy is identified. So first of all, we have seen this already, what we call as the recall. Okay, this recall or sensitivity. Recall or sensitivity, they are identified by the same formula, true positive divided by true positive plus false negative. Okay, so directly by using classification report we can see the recall. It can be called as sensitivity also. There is one more formula called as specificity. Specificity can be identified by true negative divided by true negative plus false positive. Okay, and if you are using false positive rate is equal to 1 minus specificity. Okay, or by this formula, false positive divided by true negative plus false positive can be found. How to do this one? So let's use confusion matrix. Confusion matrix I have saved inside the variable CM. So in CM variable the confusion matrix is saved, and now CM's how accuracy is actually found. CM's 0 0 and CM 1 1 positions divided by total number of elements. So I have added them, like it was 67 plus 22 I think, divided by length is 100, that is 89 divided by 100. That's what we call as 89% here. Okay, now sensitivity, the sensitivity that I have shown here, true positive divided by true positive plus false negative. So in this way true positives are present here, divided by this into this plus this. Okay, so by formula I have identified that, but sensitivity is equal to recall itself. Okay, that is 98% here sensitivity. And if you go to specificity, for specificity is this, true negative divided by true negative plus false positive. Okay, so in this way you can do this by using CM11 divided by CM10 plus CM11, and specificity is found. Specificity for this class is 68.75%. In this way this particular identification of different parameters are possible here, characterization is done. Okay, now relations, sensitivity and specificity are inversely proportional to each other. Remember, when sensitivity increases specificity decreases and vice versa. Okay, so to identify how perfect classifier is there, these particular parameters are can be perfectly used to classify or to characterize your classifier, whether you have to choose this classifier for this particular algorithm or not. Okay, so you can make use of these particular resources also for understanding more in detail about logistic regression, and you can try the system by your own, check out the probabilities, check out the things on different kind of the data sets for classification system. Thank you. Thanks a lot.